Hi, Professor. Can you hear me?
Ah,
Hi, Prof.
now I can. Yes, yes. Hi. Can you hear me?
Hi, hi,
More
Professor.
importantly, hi. Hello, how are you?
Hi. No, now you can hear me. Hi, and thanks for accepting our invites. It's an honor to have you with us today.
Oh, that's fine. It's an interesting to prepare this, and so let's see. Mhm.
Sure. And I'm sorry that I cannot share my webcam because I have access to a laptop that don't have a webcam, and I'm
Okay,
sorry for that.
right. Yes.
Okay. So, hello everyone, and welcome to the 10th round of Sharif University of Technology Winter Seminar Series. Uh, Today, we have the honor of having Professor Chris Watkins here with us. Professor Watkins started studying mathematics, philosophy, and experimental psychology, and ended up getting his PhD from Cambridge in reinforcement learning. We know Professor Watkins from the famous Q-learning algorithm, and also I have known it from Professor uh, Andrew Barto, that he's the one that gave us the formalism for reinforcement learning that we took for granted, and that's when I got interested in his works. And we also had the honor of having him as our guest previously in Sharif University of Technology. And today, Professor Watkins wants to give us a talk about pragmatics and wants to help us think much deeper about the language model and maybe helps us understand their limitation and the way forward. Uh, Dear Professor, we are very excited to have you here with us and hear this wonderful talk of yours.
Thank you very much. Thank you very much.
Thank you.
Um, I'll try and share my screen now. Let's see. Yes, going to allow everything to happen. Now, let me. Oh, I have so many windows open. Oh dear. Let's try to find the right thing. So, thank you very much for inviting me. Now, I understand it's the last talk of your workshop. I promise you, I'm not going to say anything technical. I'm not going. I'm still trying to find my um, uh, my. Oh, this is window. Oh, that was Chrome. No wonder that was that. So, right. Let's try to do that. Let's try to share this. Yes. Now, can you see my window here?
Yes, we have your screen and it's clear.
Brilliant. That's fantastic.
Thank you.
Right. Okay. Like everybody else, I'm fascinated by large language models. They are absolutely astonishing. In other talks, I have slides of exploding volcanoes to express my excitement. And we're at the stage, it's like just being just a few years after the invention of flying machines of aeroplanes by the Wright brothers. We've got the first real flying systems. We don't know what's going to happen. So, um, so what I um, I'm simply going to assume that you all know about large language models. I'm not going to explain them at all. But what I am going to talk about is research on natural language from before 2016. Uh, I'm going to say very little about syntax, even less about formal representation of knowledge, but I think that's really some useful advice. And mostly I'm going to talk about pragmatics. Now, people study some questions. I mean, it's really astounding, very astonishing and surprising. And no one expected it, that just pre-training a big neural network to predict the next word is such an effective kind of training. It seems to teach these neural networks to think. They think badly, but they do think. So, one natural question to ask is, what kinds of thinking do we do while we speak and listen? And that's what I'm going to spend most time talking about. LLMs, they are one of the fastest developing technologies in history. I mean, it's truly astounding. About 10 different companies in America and in China have released fluent and capable LLMs at about the same level. So it's not a very hard technology to build. Pre-training, predicting the next token. Now, what was I going to say? I mean, why is this effective? So, what was happening before the first LLMs, BERT and GPT, in 2017? Well, there had been 100 years of research on natural language. And many academic lifetimes, tens of thousands of people, they weren't stupid. They did a lot. And I would describe this is my term, it's not a standard term, as a grand project in three parts, what it kind of emerged into. The first was understanding syntax or grammar. The second was understanding formal semantics, translating sentences into some logic. And the third was understanding pragmatics. And the kind of dream idea, the dream was to process a sentence in three stages. You parse the sentence and produce a syntax tree. You use that syntax tree to produce as you do a statement in a programming language. Stage two, you use that syntax tree to produce a formal representation of the meaning of the sentence. And stage three, you figure out what else the speaker is trying to say. That's pragmatic analysis. All three of these stages failed, interestingly. So this is the idea of how computers should understand sentences. This all started, I think a good place to say it started was back in 1905. There's a famous philosophy paper. If you study philosophy in Cambridge, it's the first paper they give you to read, called On Denoting by Bertrand Russell. And Russell asked how we can attach meaning to a sentence which seems to be nonsense, such as the King of France is bald. I mean, the problem here is there is and was no King of France. I mean, you can say the King of England is bald. There is a King of England, and he is a bit bald. But in the King of France, there's no King of France. So is it wrong? Is it meaningless? Is it some fiction or what? How might philosophers analyze the meaning of such a thing, of such a sentence? He made a really radical suggestion. He said, translate the sentence into formal logic. So I expect if many of you are computer scientists, you've done courses in formal logic and you've seen translations like this, we can translate it as there exists X, such that X is the King of France. And for all Y, if Y is King of France, that implies that Y equals X. That is, there's only one King of France. And this is how you translate, according to Russell, the King of France, and X is bald. Now, how do we interpret this sentence in formal logic in the world that we have? The answer is it's just false. So in other words, we want to interpret the King of France as bald as there is a unique X such that X is the King of France and X is bald. And this is perfectly meaningful but false. So this is kind of neat and nice. And it's a very witty paper, and he says many other things, and it has some quite good jokes, and it had a major influence. And so there was sort of a 100-year project of trying to develop formal languages to express precisely the meaning of ordinary language, with the idea that you could clear up a lot of puzzles by doing that. So the radical idea was he implicitly suggested we could resolve questions about meaning by finding rules to translate sentences into a precise language formal logic in which the meaning would be clear. And, well, there was a lot of work on this, and much of it pretty successful. They developed some interesting formal languages. So what went wrong with this grand project? Sentence to syntax to meaning. Pretty much everything turned out to be impossible in quite interesting ways. The first problem is that word language is massively ambiguous. Even word meanings are ambiguous, and words mean different things in different contexts. The grammatical structure of sentences is ambiguous in many ways, and you may need large amounts of knowledge to understand even very simple texts. And of course, formal representations of meaning are really hard to construct and reason with. Even formal representations need to be grounded in reality. And how do you do that? What do king and France mean? Let's consider an immediate problem here. We can use words and give them new meanings perfectly happily. This is a famous example. It's a charming story about a conversation between a mother and a daughter, and the daughter is talking about the roommates for her flat, and she gets a little bit carried away and enthusiastic, and she refers to people by the objects they own for humorous effect. The daughter might just be a little bit materialistic. So we get to here. She says, "We thought we were onto a steam iron yesterday, but we were too late. Steam irons never have any trouble finding roommates. She could pick her own pad and not even have to shower a bathroom. Got one. We've had a streak of bad luck. First kind of coffee machine flunked out of school and went home. When we replaced her, our electric typewriter got married and split, and so on." So we can create meaningful words in context. So clearly, we don't have any simple process of translation into formal languages. Sentence processing must be complicated. We figure out grammatical structure, the meanings of words, and the author's intentions all at the same time. The next discovery really came from computer science. I mean, with this example, I think it's interesting when you have inadequate theories, there is a strength in having optimism that you can develop the theory. We could develop a theory of formal meaning which would cover this case and keep trying. And there's also a reluctance to recognize when things are fundamentally not adequate or not possible. So really, I think this is really a philosophical discovery or psychological discovery that was made by computer scientists. And in the 1960s, the first pioneers of artificial intelligence really thought that understanding language was going to be easy. What could go wrong? That had already been a great success with compilers and programming languages. So surely natural language was going to be very easy. And in 1972, Eugene Charniak was doing his PhD at MIT, and his supervisor, Terry Winograd, suggested that he tried writing computer programs to understand very simple children's stories. And he was a very practical man, and he went off and he got actual children's story books. So this is a real children's bit of a children's story. And then he thought, well, before I write a program to try to understand this, how can I tell if my program, my computer actually understands the story? How can you test whether the computer understood the simple story? And the idea here is that you could ask the computer questions about the story. Okay, that seems reasonable. Um, this is like a school exercise. We call it comprehension tests. And the idea is, well, you can't just ask any question. That's too much. You want to ask fair questions about the story. Questions which, if you understand the story, you really should be able to answer that question. So, what's a fair question? Well, I think a fair question with this story is it should be able to say what this magenta it refers to. That seems fair. It's a good question. Oh, by the way, please do interrupt. I can't see the chat, but if anybody's got a question or a comment, hey, this is the end of the day. This is an informal talk. Please join in and ask me. I'll be very pleased to hear any questions or comments from you.
Everybody, if you have any question, just raise your hand. I'll give you the microphone access. And thank you.
Okay, right. So let's just consider what it takes to answer this question about this story. Well, let's just think about it for a moment. Um, what does it refer to? Well, the only things that were not people which have been mentioned, well, it could be the store, it could be the presence, it could be a football, or Jack has a football. Oh, wait a moment, there are two footballs. So usually it refers to the noun, the closest noun previously, which is not a person. So it's not going to refer to he, but it could refer to this football here. It's natural to assume it refers to this football. But this is the wrong football. In America, apparently in the 1970s, if you're a child and you go to another child's birthday party and you bring a present, and if your host, Jack, already has the same thing, then he can ask you to take your beautiful present back to the store and get him something else. Wow. Okay. But we can kind of infer this from this story. He'll make you take it back. This it refers to this football that Janet might buy, not that one. Now, to make that inference, there's nothing in the surface structure which leads you to think that that's so. This is kind of deep reasoning from cultural knowledge. It indicates that it's this football that Janet shouldn't buy that it is referring to. So Choniak found a number of examples like this, and he realized that philosophers really hadn't, they hadn't contemplated writing a program to understand stories or answer questions about them, and that to understand even the simplest children's stories for grade school children, there are sometimes there are unlimited amounts of reasoning, and we also do this reasoning almost without noticing it, kind of unconsciously. So I think this was quite a major discovery. LLMs, they were developed by engineers who perhaps had very little knowledge of or interest in previous research in computational linguistics or linguistic philosophy. And let's look at some other ways in which the grand projects failed, because we don't know why LLMs succeed. Let's think about syntax or grammar. Maybe for a very long time, maybe Aristotle was the first, or maybe he wasn't, there was the idea that each word is a part of speech. So if you, at school, I'm sure when you went to primary school, when you were about 8 or 9 years old, you're taught about nouns and verbs and adjectives and adverbs, preposition, conjunctions, pronouns, interjections. For computer scientists, it's kind of useful to be able to automatically recognize parts of speech of words. But this seemed universal and true. And then I'm sure you started learning more complicated things, and you always believed that this was true. There are kind of 8 parts of speech. Well, there are a few more than that. There are opens and closed classes. There are proper names and proper nouns and common nouns, and verbs. There are different kinds of verbs, and there are some and particles. You can distinguish so many different classes of words. There is a kind of universal set of parts of speech, which the computational linguists have found that applies to nearly any language. But it's not enough to write a decent grammar with. To try to write one of the first huge projects was to take a data set of, I think, millions of sentences taken from the newspaper, the Wall Street Journal, and to parse these into syntax trees. And they needed, well, your syntax tree ends with these parts of speech. And so they defined 20 or 30 parts of speech here. It's still not enough, but it was as many as they could. Nobody's ever been able to agree on a sufficient number of parts of speech. What's the problem of understanding the grammar of a sentence? If you're given a sentence in some socially agreed language, the problem is to find some syntax derivation as the subject, the verb, the object, all the relationships of the different words in the sentence. That's a correct analysis of the structure of the sentence. There's fairly good agreement on what the correct analysis of the structure of a sentence is. People think they're trees. The problem is that a word can play different roles. Words can be both verbs and nouns. Even the short, simple words can be both prepositions and conjunctions and so on. And sentences are also structurally ambiguous. Even if you can agree on all the syntactic roles, one sentence may have thousands, even tens of thousands, or sometimes millions of possible syntactic structures. And this was, again, something else that was only discovered when people wrote computer programs to parse real natural language sentences. It was completely unexpected. It seemed that any grammar you constructed, which was good enough to give you the proper structures of sentences in English, it didn't just give you one structure. It gave you sometimes 10,000 structures. And if you looked at those 10,000 different tree structures, if you looked at them very hard, you could see that, they were possible interpretations. Sentences were far more ambiguous than anyone had ever thought they were. You could not build a parser to go from a sentence to its syntax tree. Now, so the problem is that any grammar that is big enough, it's got enough possible rules to parse most sentences in a language, will provide many different possible parses. In this case, a classic example is that it is a sentence, every boy loves some girl. And here there is an ambiguity because there might be, it might be that every boy has a different girl who they love, or there might be one girl that every boy loves. And these are two entirely different presentations of the meaning of the sentence. Once again, this is one of, I'm sorry, this is one of my favorite examples, but it's quite a difficult one. So this was a headline in the Times of London newspaper, and the headline was, "Hospitals named after sandwiches kill 5." When you look at this and you think, do you really name a hospital after a sandwich? Am I going to say this hospital, is there a place called the Cheese Sandwich Hospital? This is really strange. And hospitals kill people? And it has this perfectly possible parse as a newspaper headline. So this tree structure is syntactically plausible on the surface level interpretation, but is absolutely not appropriate for the meaning. And this is an entirely different parse. The hospitals named, that is, somebody published the names of the hospitals after sandwiches killed 5 people because of food poisoning or allergies or something like that. So even very simple sentences can have radically different and unplausible parses. Other types of when language was closely examined and people collected large numbers of examples of sentences, thousands of examples, and they applied automatic parsing programs to it, they found it was absolutely normal for sentences to be structurally ambiguous, to be multiply ambiguous. If you say, "I saw the man in the park with the telescope," did I look through the telescope and see the man in the park, or did I see the man in the park who was carrying a telescope? Those are two interpretations. So they're extraordinarily, this language is extraordinarily and unexpectedly ambiguous, and which meaning you want depends on the context. So it turns out there are a whole range of ideas that seem clear, but which are not clear when you closely examine them. What's a word? What's a part of speech? What's the syntactic structure of a sentence? What's the grammar of a language? There is absolutely no generally agreed grammar for English. What is the meaning of a sentence? Let's go to here. So,
We,
well,
we,
that's.
we have a participant that raising his hands.
Oh,
Let me,
please do. Yes, yes.
sure.
Hi, Professor.
Hi.
I have a question, but I'm not so sure about it.
Go on.
What can the Pragmatics tell us about the limitation of the current LMAs?
Um, that's a great question. I'd love to be able to tell you about limitations of LLMs. Um, the LLMs seem to solve most of these problems much, much better than anyone's been able to solve them before. And at the moment, we really don't know how. But what I'm doing here is I'm going through this informal sketch of the state of knowledge in 2015, just before the LLMs were, transformers were invented, to see what the problems were that these transformers so surprisingly solve. Actually, even Claude and GPT-3 cannot disambiguate this sentence. Hospitals named after sandwiches kill 5. This sentence, they can't understand. They interpret it as hospitals named after sandwiches kill 5. They suggest maybe the Mayo Clinic in America. There's a reason for that. It's one of the rare examples where you can actually produce a sentence that an LLM doesn't understand. But generally, they are very good on working through a sentence, and somehow, and we know some, but not much, about how they do it, keeping all the possible syntactic interpretations in mind. I'm sorry, your question's absolutely right. I wish I could answer your question. All I'm doing is I'm saying what people used to know. So I don't know if you've been through a good old-fashioned natural language processing course, then this is... So,
Thank you,
so it's a bad answer. Your question is a good one.
It's a great answer. We really don't know.
I mean, no. So the grand project failed badly for syntax. Well, that's not quite true. You can still go on the internet. You can download the best rule-based parser from Stanford Core NLP parser. You can run it on your laptop, and you can give it random sentences, and it gets about 9 out of 10 correct. There are still some simple sentences it doesn't do well, but they got to a decent level of performance. And you could see they really wanted to improve it, but getting it to close to 100% was really impossible. There's a small piece of advice. After looking at the second part of the grand project is formal representation of knowledge in a formal language. Now, many of you will be starting research projects, and in those research projects, you may want to represent knowledge about the world in some formal way. And my strong advice is don't just make it up. Get a book on you can just look up recent references to knowledge representation languages, and there is 50 years of research of people who've been trying to do this, so you don't make the mistakes. You don't have to invent everything from scratch. But it's really not my area, so I'm not going to say any more about it. What I am going to talk about is something even worse. The grand project failed even more. And it failed because there's a very subtle question. What is communication? How do we define communication? If you're an engineer, you say, well, this is real simple. We put a signal in one end of a wire, and then we're getting a signal out of the other end of the wire, and we remove the noise, and we decode it, and we've communicated. Is that what language is doing? So our first idea you might have for defining one person communicates to another, let's try to say it very carefully, is person A communicates some fact X to person B if A causes B to believe X. Seems reasonable. Is this a good definition of communication? Is it what we even normally mean by communication? Well, the answer is not quite. So I'm going to take a little Oxford philosophy example. And these ideas in the rest of the talk really come from one Oxford philosopher from the 1950s, 60s, and 70s. So let's imagine an ancient village, maybe before the invention of language, and suppose there's a wise man in this village, and he wants the young people to believe that a mountain path is dangerous. So let's have a little picture. Oh dear, I can't see. Oh, I can't see everything on the right side here. This is supposed to be a rocky cliff. And here is the dangerous path on the cliff. You don't want to walk along that. So how does the wise man get the young people of the village to believe it? Well, he goes out, gets up early in the morning, he kills a wild beast, and he places it below the path as if it fell off. And the young people get up later and they say, wow, that beast has fallen from the path. The path is dangerous. The wise man has succeeded. They understood. But I think you might agree this is not what we normally mean by communication. It does seem like a lot of trouble. And it's very indirect. He's set up, the wise man has to set up a whole scene in order to persuade the young people to believe this. So what do we normally mean by person-to-person communication? Well, we communicate by recognition of the intention to communicate. We don't normally trick people with elaborate preparations, even when our intentions are good. Instead, the listener recognizes that the speaker is trying to communicate something, and the listener tries to figure out what the intended message of the speaker is. The listener recognizes the speaker's intention to communicate and uses the context to figure out what the speaker is trying to say. So let's look at a different scenario. So some generations later, a different wise man uses a different approach. He kills a wild beast and then drags it towards the cliff, but this time the young people are watching. And he's dragging this wild beast towards the cliff and kind of pointing up to the path. And you can imagine the young people saying, what's the crazy old man doing? Maybe he wants to tell us something. He's dragged the beast onto the cliff. Why would he do that? Well, it kind of looks as if the beast fell from the path. Maybe he's trying to tell us the path is dangerous. That would explain his behavior. So that's what he's trying to do. So this is completely different reasoning to interpret the old man's message. They must recognize his intention to communicate. I notice that this time, the success and failure conditions for this communication are really quite different. I mean, we don't have to have it's so realistic that the animal needs to have fallen from the path. The idea the young people just need to be able to interpret the dead animal as if it might have fallen from the path. And also, if they think the old man is absolutely crazy, then they can choose not to believe him because they just don't believe him. They say, he's trying to communicate that the path is dangerous, but it's not. I walk along the path all the time. So the conditions for success and the conditions for failure are really quite different. And the young people have their beliefs changed for entirely different reasons. But again, we're communicating with play acting here. So it's a lot easier if you're going to use language. After the invention of writing, it's much easier to use conventional standard language rather than inventing some special communication method. The underlying logic of the recognition of the intention to communicate remains the same. It's just that you don't have to think very much. It's kind of obvious. In this case, recognizing the intention to communicate is easy and requires really no thought. It's another safety notice. The path is dangerous. Right. So notice that if they, again, sometimes this requires no thought. In other contexts, this might require considerable thought. For example, if they haven't noticed the path, then they say, why is the sign saying dangerous path? There must be some path. Maybe they mean that path. maybe, again, it can fail if they don't believe it, if they have seen these signs and they think that the local village council, village government is just putting up far too many signs everywhere, and it's not true. Pragmatics, the language can also be used more creatively. Here's a non-standard sign, which requires a bit more interpretation. You can say, you will enjoy the fall. Well, this looks just like a safety sign, but what fall do they mean? Maybe if you go on the path, you might fall. But I would not enjoy that fall. Well, it makes sense if the message on the sign is sarcastic. It means the opposite of what it says. It means that if we take the path, we may fall, and we won't enjoy it, especially if we land. Okay? So there's still inference happening. So the Oxford philosopher Paul Grice introduced a new term, implicature. He needed a new word. It's an implicature is an implication that the speaker wants the listener to make, and the speaker and the listener are mutually aware that the implication is intended. It turns out that we seem to do this all the time. Some examples of conversational implicatures. I was talking to a friend about giving this lecture, and he said, "Oh, you're going to talk about pragmatics." Well, most people make pragmatics much too interesting. All these pragmatic inferences, these implicatures, they're all really boring. That's so boring and obvious. You don't even notice they're there. So let's consider a direct request, which literally means open the window, is please open the window. But you can say please open the window in so many other ways. You can say it indirectly as can you open the window? Well, the literal meaning of can you open the window is are you able to open the window? I mean, do you have hands? Are you strong enough? Well, sometimes it means that. I mean, can you open the window, or has it been stuck shut? Does that window open? You can say it's hot in here, or we need some fresh air. If someone says it's hot in here to you, you might say, yes, okay, well, why are they saying that? What are they intending? What is the purpose of the conversation? One way in which someone saying it's hot in here can make sense is if you are next to the window, it's cold outside, and you could open the window, in which case it's probably an indirect request for you to open the window. This is known as an indirect speech act. None of these literally mean open the window, but they're all easy to interpret with this meaning in an appropriate context. But again, using logical reasoning here is a little hard. So Grice gave an informal framework, which is astonishingly simple. He argued that speakers and listeners understand each other by assuming that conversation is cooperative. And he proposed as a start 4, if you like, maxims, 4 rules of cooperation. There's a rule of quality, which is to say only what's true, or don't say what you, if you haven't got evidence, don't say it. It's not helpful. Quantity, give as much information as necessary and no more. Don't give too much information. It's confusing. Relevance, make your remark relevant to the purpose of the conversation. Manner, be clear, orderly, unambiguous, with language appropriate to the context. And let's have some examples of conversational implicatures. So 2 people are driving in a car on a long road trip. Driver, there is 1/10 of a tank of gas left. Passenger, there's a town 5 kilometers away. So what's happened? The passenger interprets the driver as saying, hey, we need we need to buy some gas or petrol. I don't know if you call it gas or petrol in Iran. Gasoline. The driver understands the passenger. So saying there's a town 5 kilometers away could seem completely irrelevant to this. You're talking about a town 5 kilometers away, and he's talking about gasoline. So what's the relevance? Well, in this context, the relevance is very obvious. There may be a gas station where you can buy some gasoline in the next town, which is 5 kilometers away, which is a short distance. We should easily be able to drive that. So the passenger recognizes the driver's purpose. The driver recognizes the passenger's the relevance of the passenger's response. So here's a nice one. Your roommate goes out to buy bread and milk. He returns and says, "I got the bread." Well, may I ask you, did he get the milk? Did he? Yes or no? I think there's a very strong assumption here that he didn't get the milk. It would be, he could say, "I got them," or or yes. But if he says, "I got the bread," then he doesn't mention the milk, then he probably doesn't. That can be context, of course, and where getting the bread is really the achievement. Milk is very easy to buy. Suppose that in the context, milk is very easy to buy, bread is hard to buy, bread is really hard to find, then saying, "I got the bread," that's triumphant, and well, of course he got the milk. So it really depends on context. Another example, you went to go to see a movie with a companion, and afterwards you say, "Did you enjoy the movie?" And your companion says, "The popcorn was delicious." Well, did your companion enjoy the movie? You have to say, well, probably not, because this reply is not really relevant to the question. So then, once again, the speaker, you need to think, why might my companion have said the popcorn was delicious when I asked, "Did you enjoy the movie?" Well, maybe they don't want to give their opinion of the movie, and their opinion is bad, so it would be impolite. So they say something positive and nice instead. So in each of these examples, there's kind of inference, sometimes very easy inference. And so Grice's idea, which has been much developed by others since, is that people understand each other by recognizing each other's intentions to be cooperative. And this enables people to communicate more than the exact or literal restricted meaning of what they say. Sometimes what people say can be immediately interpreted as cooperative, and at other times, other examples are less standard and they require more thought. In my experience, LLMs are really good at it. So, what are some characteristics of implicatures? How can you? The first thing is that there are, people say, three main properties of implicatures. First of all, they have to be calculable. The listener has to be able to figure out or calculate what implicature the speaker intends. Implicatures allow you to be efficient. They allow you to say more than you mean, to extend the meaning of what you say. That's certainly one of their functions. And so in all of our written language and spoken language, we're constantly making jumps in such a way that we expect the listener or the reader to fill in the gaps. So, but we mustn't make our jumps too big, otherwise the listeners or readers totally fail to understand everything we say. Next, they can be context dependent. Implicatures may depend on and be modified by the shared context of the speaker and the listener. And thirdly, this is quite interesting. They're cancelable. You can cancel it. The implicature doesn't contradict the literal meaning of the statement. The speaker can retract it in the next sentence. Let's take an little example of that. I couldn't resist making this one a joke. The example here. So there was from the 1930s, and in the 1930s there was an American comedian called Groucho Marx, who was very well known for his rapid, quick-fire wit. And he went to a party which he didn't really enjoy. And as he was leaving, he said to the host, "I've had a perfectly wonderful evening." Well, there's an implicature here. You may not even notice it. I've had a perfectly wonderful evening. So we assume it's relevant to the party and the context. So we assume it refers to this evening, but then Groucho Marx added, "But this wasn't it," thus unexpectedly cancelling his previous implicature. Now, this implicature is so natural that seeing it getting cancelled like this is a bit of a shock, and it's very rude. But it can be cancelled, and it doesn't contradict the first part of the implicature. So your next question, if you're still surviving so late in the evening, is, have people tried to formalize these implicatures? The answer is yes, but it turns out to be really hard. Formalization has really only so far been attempted for restricted special cases. The type of notice this date, 2016. I mean, this is difficult work. It's people try it for what are known as scalar implicatures. A scalar implicatures is when you're making a statement which implies a meaning on a particular quantity scale. So, for example, if I say, I have some children, it kind of means I've got more than one. A logician might not agree with that, but the implicator is I've got more than one, otherwise I would have said I've got one child. If I say I have 3 children, well, there's a very strong implicator that I don't have 4 children or 6 children. Why would I say 3 if I actually have 4? It's true that I have 3 and I've got another one as well, but I wouldn't say that. If you say some students pass the exam, there's quite a strong implicature that not all the students pass the exam. But notice that's cancelable. You can say some students pass the exam. In fact, all of them managed to get through, and you haven't contradicted yourself. Now, the key idea of the formalization, and it's a really difficult idea, is that speakers and listeners adopt rational conventions to maximize informativeness relative to sentence complexity. Whoa, this is game theory. More generally, understanding speech and text requires reasoning about the mutual context and the intentions of the speaker. That's hard. And this reasoning is really difficult to formalize and seems to require construction of a game theoretic optimum in which the speaker uses least effort and conventions to ensure the listener can draw the strongest conclusions. So maybe that we've developed really quite intricate and complicated conventions about implicatures over time. That, the speech community, people speaking to each other, speakers and listeners, have gradually been finding or approaching some game theoretic optima in how to efficiently communicate by the choice of what they say. I think that hasn't really been studied yet. So in conclusions, what have we learned? Well, learning isn't really much. What questions have we found? The first point is that it's been known really since the 1990s that interpreting natural language requires simultaneously and mutually dependent inference of speakers' intentions, grammatical structure of the sentence, and the intended meanings of the words in context. You really have to do all three together. And there are examples where it's clear that each of these comes first. When we implement, in a general point here, when we implement informal ideas on computers, the scale and precision that you need reveals new underlying problems and new phenomena. just as Charniak found, and the syntax people writing automatic parsers found. And in general, understanding language requires understanding implicatures, which requires mutually agreed reasoning of the speaker and listener. This is hard to formalize, and existing philosophical rather than theoretical here, frameworks are informal and qualitative. But large language models do a really good job, a massively better job ever than any previous systems in handling implicatures. So maybe what this is telling us is that about language is that much of the required reasoning is much more highly standardized and pattern-based and conventional than we realize. I think these are really open questions. So that's just a shallow tour, little bus tour of the grand project of computational linguistics before 2016. Okay, that's. Have you any questions?
Thank you, Professor. We have some audience that have question. I'm gonna get.
Shall I stop sharing and then I can maybe I could if you maybe you don't have a camera.
Yeah, let me.
Oh, I think I've stopped sharing now. Can you see me?
Yes, we can see you.
All right.
Can you hear me?
Yes, I can. Yes.
I'm sorry, I don't have a camera. So
that's okay.
Yeah. I have two questions. I think I got pulled a little bit too much into the philosophical world of the talk. But the first question is, when we were talking about a path in the hill and the elder person trying to warn the younger people,
right.
We had 4 alternatives in which some of them, it was harder for the younger people to interpret what the older person was trying to say. And in some, the older person had to put in more effort to convey the meaning. And in LLMs, or like in general in machine learning and in AI, when we're working, we have some people who are working with the AI, and we have the AI who's trying to, give some answers or convey some meanings or understand some things. Would we rather it be harder for the AI to interpret, because when it is harder, we have the risk of the AI making more mistakes, or would we rather we have to put in more effort for the AI to understand what we want it to do for us?
What a nice question. This is going to be great. Everybody's going to ask questions, and my answer is always going to be, I don't know, and that's a nice question. I mean, this would bear directly on the the RLHF, the post training of the LLMs. I mean, what should you train it to do? And one thing you notice reading LLM output is that often it doesn't obey the maximum of quantity. It just goes on, it gives you too much information. And I think one of the so I don't know why that is. I would suspect they would rather that the LLM gave too much information too slowly, so that it was very easy to interpret, rather than that it gave too little. So I mean, I don't know why that is, and there could be many reasons for it in the post training and the types of answers that they don't want it to not give the information. And the second reason why the LLM gives too much information is, of course, that they're trying to get them to do chain of thought reasoning, that the only way the LLM can think is by speaking, so that it creates new representations as with each new token, and that's how it thinks in order to get through to the answer. And in using LLMs, I find it is much until recently, it was much better to be over long and over clear in typing my question. So I would usually write a whole paragraph asking for what I wanted. And you ask the LLM to be long in its reply to gather, to set out all the relevant information and then produce an answer. And this worked very much better. But and you have to remember, each time you speak to each conversation with an LLM, it's starting from scratch again, so it's a new context. And if you start off a conversation with an LLM, the context of the conversation may be clear to you, but not to it. You're speaking to it for the first time. I don't know if this answers your question at all. I think it's very, very nice. There is not enough work yet on testing whether LLMs can interpret and produce appropriate implicatures. There is some work, but not very much. And it's not very analytical. It's just people putting together big test sets of examples of implicatures and then seeing if the LLM understands them. Or, sorry, that answer's too long and too short because I haven't really answered your question.
No, it was perfect. Thank you. And may I ask one more question?
Of course.
I had a question about the dual meanings of the sentences and the fact that the pragmatics have a big role in how we define and take in the meaning of the sentence.
Yes.
And there are some sentences that human minds cannot, take in and think about and figure out what it actually means. Like if I said she weighs 5 stones, does it mean that she's weighing 5 stones or that her weight is 5 stones? And
right.
Yeah, and could we expect LLMs to understand what we do not understand?
I think, okay. There are, the first thing to say is in the decoder style causal LLMs, it's very remarkable that they seem to maintain a wide range of possible interpretations of the sentence as they process from left to right. So I think if you could devise some, your example is very nice. If one did some experiments with GPT, a good big modern language model, I'm willing to bet that it will have both of the interpretations of your interpretations in it. Now, at the moment, we are all happily speaking and giving LLMs training data, which they are imitating. But it would seem that if we had some theory of how these game theoretic equilibria for implicatures are created socially in a community, then LLMs could indeed construct new ones. So that's certainly, I hadn't thought of that. I mean, actually, it's quite a promising direction for LLMs to find new ways of communicating, because to make implicatures, I'm starting to think that the idea of implicature is even more widespread and important in natural language than has so far been recognized. In that, when you talk about anything, even if you're describing a scene in front of you, if I describe the street I can see through my window, I will give a series of descriptions, I'll state a series of facts. And what I'll be doing is each time I make a jump, I am relying on the listener to connect those facts together, to connect up the picture. And so I can't jump too far each time. But maybe LLMs, if they speak to each other, they will be able to jump further than we can, or jump in different ways. I really don't know. It's a very nice question.
Thank you very much, Professor. Thank you.
Okay, thank you, Professor. I have another question that
Great.
I submitted through the form. Let me read the question for you. Someone asks, Noam Chomsky and Jan LeCun say LLMs doesn't tell us anything about human intelligence. What's your opinion on this topic?
Well, they don't tell us anything very much about human intelligence yet, because we don't know how they work. But so to understand something about human intelligence from LLMs, we have to understand a bit better mechanistic interpretability of LLMs. The kind of work that Anthropic has been doing, for example, is very interesting. The two Anthropic blog posts which have been published. There was one paper this year and one paper last year. I mean, if we say, well, an LLM is a very complicated neural network, and we've really no idea what's going on inside, then of course it can't tell us very much about human intelligence. There is work on looking at the similarities between LLM activations and activations, neuronal activations in the brain, and people have found some similarities. I'm really not an expert on that work. I think there's the researcher to start reading on that is a woman called Ev Fedorenko at MIT. That's Fedorenko. And I mean, I feel there is, what strikes me about LLMs is that where I find they do best, where they are really unconfusable, is in little simple stories about people. I mean, if you take an LLM and you go into some obscure area of science and you ask it more and more detailed questions, you pretty rapidly get it to hallucinate. But if you have stories about people, its interpretation is astonishingly precise and very good. And why is that? I suspect because the LLMs have been trained on every work of fiction that's ever been written and put on the internet. The whole lot, every novel, every poem, every short story, every piece of fan fiction, every film script, you name it, every story that's been written down and which any of these companies could steal has been used in training them. So the amount of training data they have on stories is more than anything else. So, and astoundingly, if you ask LLMs to explain about implicatures, they're extremely good at it. Even though I bet it's.
Thank you. We have two other people raising their hands. I'm going to give them the mic.
Please do.
Can you hear me?
Yes, I can hear you.
Okay, so greetings and good afternoon.
Good afternoon.
We have a chance to ask my questions. It's been a while that I'm reading about search engines, especially private search engines. I had the chance to start a book by Trey Granger. I hope I could pronounce the name right.
Mm-hmm.
The title is AI Powered Search. After your presentation, I have a question about pragmatics, and I think it's been less talked about in context of search engines. And now I'm curious that why is that? Is there any specific reason, or it's a gap? It's a research gap. Thank you.
Oh, yeah. Well, in search, I mean, I don't know the detail of it, but certainly for the heads of research on search at Google some years ago said that the main problem is inferring user intention. That users have an intention when they search, there's something they want, and figuring it out from what they say is very hard. One aspect of pragmatics, which is certainly important in search, is figuring out the sense of a word in context. I think that there used to be a problem on Google that can you imagine two search queries? One of them is visa from US to Brazil and visa from Brazil to US. Well, these really overlap in nearly all the words. So if you do any bag of words approach, you're going to retrieve the same documents. And this will be deeply frustrating to the users because if you're in Brazil, you want to go to the US, it's a completely different problem from being in the US and wanting to go to Brazil. I mean, it's totally different. And after BERT, BERT manages to produce embeddings of words in context, which are sufficiently different from and to destinations. For Brazil and the US, from Brazil to US and from US to Brazil, the embeddings of the US and Brazil are sufficiently different in each case, that now they really could disambiguate them. So the breakthrough, as far as I'm aware, in search was from embeddings from systems like BERT. I don't know if that answers your question, but it's unfortunately I'm not employed by Google. If I was, I probably couldn't tell you.
I could grasp some ideas. So you think that pragmatics can solve some problems in search? As mentioned, the ambiguities about around some queries. The pragmatics can solve some challenges regarding to queries, right?
Well, I wouldn't quite put it like that. I would say that the problem in interpreting a query is solving the pragmatics, and that's hard. So there are I would expect that probably the best way to do it at the moment is to put the query into a good, big, large language model and say, can you paraphrase this longer? And then you put it into the Google query system.
Right. Yeah, that clarified for me. Thank you.
Okay.
So, Professor, I wanted to ask about the neural links and the connection between the LLMs with the modifying AIs that learns from our knowledge.
You mean the brain-computer interfaces?
Yes, something like that.
Oh gosh, I don't know. You've just reminded me that I meant to read an interesting paper which explained why we're so slow. That we seem to be able to produce about 10 bits a second of output, but we get a lot more sensory input. So why is our mind so slow? That Elon Musk hoped that we'd get high bandwidth communication with Neuralink, but that there was a paper which is in my stack of things to read, which argues that for reasons why we are so slow. I'm sorry, I don't know anything about Neuralink, and it's a fascinating subject, but. I'm sorry.
Thank you, Professor. We have another audience raising his hands.
Professor, can you hear me?
Yes, I can. Yes.
I have a question about, I think, again, not Neuralink direct,
Mm-hmm.
but I think in future we can communicate with each other, not text to text, context to text, and text to context. For example, between two persons. I
Mm-hmm.
mean that can we communicate context to context. I mean that, for example, a person thinks and the chip or I don't know implant chip uh, can recognize that difference in his or her neurons by his or her history and translate it to other person and by his or her history and I mean that directly
Right.
translate
Right.
context to context.
Wow. I, I've I've never thought about this, but what I was saying about the importance of pragmatics, I mean, one view of the importance of pragmatics is that it makes our communication more efficient. We say more with less, because we are. Let me give you an example of saying more with less. If I say, I am going to Paris this weekend, my mother lives there. I haven't said I'm going to visit my mother, but it's a very strong, well, it's quite a strong implicature that maybe I'm going to see my mother when I'm in Paris because of the assumption of relevance. And there are many examples where you can draw more conclusions. So it kind of speeds up communication of relevant pieces of information. Now, if we can have higher bandwidth or richer communication in some way, one view might be that pragmatics is no longer so necessary. And another might be that we'd still try to develop even better pragmatics for the new kind of communication. I don't know. It's the kind of second time this idea's come up in the questions. Um, Jeff, so okay, let's look at it this way. We develop pragmatic systems over time, and you can see this in politeness systems. So in English and in European languages, you say please. This comes from if it pleases you. So if you are going to ask someone the way to the bus station, for example, you see a stranger, you say, excuse me, if you don't mind, could you possibly tell me the way to the bus station? To soften it. That's a very polite English style way to do it. Slightly over polite and old fashioned. And the whole structure of indirect requests is based over whether they want, if it's not too much trouble for them, if they want to do it, and if it pleases them, and so on. And this has grown up over hundreds of years. A completely different politeness structure happens in Far Eastern languages like Korean. In Korean, you might say, teacher, where's the bus station? Or honorable teacher, where's the bus station? So you do it. If you said that in England, people would think you were mad. But in Korea, if you use the English method, people would think you were mad. So there's a lot of conventions that have grown up. And so I really hadn't thought of it before this question and the previous questions, that learning to use different types of communications, maybe we will need to learn new pragmatic conventions. I mean, just imagine if you could put images from your mind into somebody else's mind. Well, we're going to have to figure out some rules on how to be polite about this. How do you start? What images do you start with? How do you start the conversation? You know, I don't know.
Thank you, Professor. Unfortunately, we cannot get more questions because our times is up, but we are very happy to have you here with us, and we are honored to have your talk. And I believe the audience get very insightful ideas about the language, and maybe they help them with the understanding of LLMs and taking new adventures in research in them. Thank you.
Great. Well, thank you for all your questions. It's been really interesting. Thank you.
Thank you, and have a great rest of the day.
Okay, thank you very much. Bye now.
Bye.
Mhm.